Okay, this is a video about factoring the difference of two squares. And that basically means is that there are some special forms of quadratics that end up kind of following a pattern. And the pattern, as I'm going to underline right now, is that if you have two squares, for example, a squared minus b squared, it's going to factor into a predictable pattern of a minus b times a plus b. That said, let's go ahead and check out how these things work. So, first thing we do is that we recognize that we have a difference of two squares, like in example number 1. It's a difference of two squares because we have x squared, and then we can go ahead and write 16 as 4 squared. Okay? And so once we have 4 squared, which is going to go ahead and match the pattern that we see up above, so we have x squared minus 4 squared, the difference of two squareds. It goes ahead and follows the pattern that we can bust it up into x minus 4 times x plus 4. And just like that, we're done. That's how you go ahead and factor those guys out. And you may go ahead and have a coefficient in front of the x squared, like for example this 4 right here. But we just have to remember that we're looking for perfect squares, and we know that 4 is a perfect square and 49 is a perfect square. So therefore, we can kind of verify that these are two squared by saying, hey, 4x squared is actually 2x to the second power minus 7 squared. And so therefore, we're using the same pattern that we see above, is that since we have the difference of two squares, we take those and go 2x minus 7 and 2x plus 7. And that is completely factored out. And then sometimes we have a hidden difference of two squares where we have to go ahead and factor something out first. And in this case, we're looking for what's in common with a 3 and a 75. And we know that in both of these, we can go ahead and divide in a 3. So we're going to go ahead and take a 3 out of here. And that's going to leave us with x squared minus 25. So now, just looking at this part right here, we have a difference of squares. So we have x squared minus 25, which we know that 25 is a perfect square. So let's go ahead and rewrite this just to keep our steps the same, where we have x squared minus 5 squared, just like that. And therefore, we have the difference of two squares, so we can use the pattern to go ahead and factor this out to 3 times x minus 5 times x plus 5. And that's really it. We're looking for patterns, recognizing when we see the difference of two squares, and then applying the pattern that we see right here to such things to factor them out quite easily. So, thank you for watching, and that's how you do that.